Determine the sum to infinity, that is 3.1. So we know fully well that the sum to infinity is given by a divided by 1 minus r, where a is the first term. In our series, a is 2. That is easy to see. So a is 2. But what is r equals to? R is equals to the ratio of any two consecutive terms. So we can say r is t2 divided by t1, or we can say that it is t3 divided by t2, any two terms that are next to each other. Well, we can also find r using t3 and t2. Well, t3 and t1, but in this case, that won't be necessary. t2 is 2 over 3, as we can clearly see, right? And t1 is 2. So this is equals to 2 over 3 multiplied by 1 over 2. So this is just equals to 1 over 3. So here we go. We have a, we have r. We can go ahead and then say that the sum to infinity, well, it is equals to a, which happens to be 2, divided by 1 minus r. R is equals to 1 over 3. So we have 2 divided by 2 over 3. So this will be equals to 2 multiplied by 3 over 2. 2 and 2 cancels out. The sum to infinity is 3. That is 3.1. We have the value of a is given to us. We just had to determine r and substitute in the formula and get the sum to infinity, which is equals to 3. What about 3.2? Show that the sum of the first n terms of the series is given by this expression. Well, we will see how we can get there. Let's start with the basics. Sn is equals to a multiplied by 1 minus r to the power n divided by 1 minus r. Okay, r is less than 1. So we are interested in the sum of n terms. Okay, so not the sum of any specific number of n, but just the general formula for the sum of n terms. So a, we already know that a is 2. 1 minus r is 1 over 3, like we determined. So we have 1 over 3 to the power n. Everything divided by 1 minus r. So that is 1 minus 1 over 3. So we will get 2 multiplied by 1 minus 1 over 3 to the power n divided by 2 over 3. Okay, we're making progress. So let's multiply out by 2 on the numerator. We'll get 2 minus 2 over 3. Oh, wait a minute. That is incorrect. When you multiply 2 by 1 over 3 to the power n, the 2 just becomes a coefficient of 1 over 3 to the power n. We don't say 2 over 3. So this is going to be 2 minus 2 multiplied by 1 over 3 to the power n. Okay, divided by 2 over 3. Instead of dividing by 2 over 3, we can write it as multiplied by 3 over 2. I think that is how we get to what we are supposed to get ultimately. Okay, so this is going to be equals to 2 multiplied by 3 over 2. We are multiplying out by 3 over 2 now. Minus 3 over 2 multiplied by 2 multiplied by 1 over 3 to the power n. So take a look at this. 2 and 2 cancels out. We are left with 3. 2 and 2 cancels out. We are also left with 3. So minus 3 multiplied by 1 over 3 to the power n. Well, this is just 3 minus 3, 1 over 3, everything to the power n. There we go. We have showed that the sum of the first n terms of the series is given by that expression. Not too difficult. Well, I would expect most people to at least get to this point. Okay, and what you do from there on is really up to you. I think there might be a couple of different ways you can actually progress from there, but that is besides the point. Let's take a look at 3.3. So 3.3, calculate the smallest value of n for which the sum of the first n terms is greater than 2.99. So we need Sn to be greater than 2.99, but Sn is 3 minus 3, 1 over 3 to the power n. We need that to be greater than 2.99. So the first step, the first organic step is to take 3 to the right hand side. So we're going to have minus 3, 1 over 3, everything to the power n, being greater than 2.99 minus 3. So let me put that in my calculator. 2.99 minus 3, that is, well, load shedding, so I can't really see. Minus 0.01, minus 0.01, so greater than minus 0.01. So minus 3 multiplied by 1 over 3 to the power n. Okay, so let's divide both sides by minus 3. So we're gonna get 1 over 3 to the power n. Well, the inequality sign changes when we divide by a minus sign, okay? Because if 4 is greater than 2, when you divide both sides by minus 1, minus 4 is no longer greater than minus 2, right? So every time you divide by a negative 1, the inequality changes where it is pointing. So because we are divided by minus 3 there, it is going to change and be what we are saying it is then. Okay, and then minus 0.01 divided by minus 3, that is 1 over 300. So we have 1 over 300. Okay, let's take a look. How can we progress from there on? Well, we can introduce the log on both sides because n is there at the top. So n log of 1 over 3 is less than log of 1 over 300. Okay, let's progress. So dividing both sides by log 1 over 3, n should be less than log of 1 over 300 divided by log of 1 over 3. So n is less than. Okay, so let's take a look. Log of 1 over 300 divided by log of 1 over 3. Let's see. I'm getting 5.1918. Okay, so the question says calculate the smallest value of n for which the sum of the first n terms is greater than 2.99. I'm getting n less than 5.1918. That is a bit weird. Should I have said critical values and change the equal sign to equals to and then figure it out manually? Okay, let me just say that n, well, let me say critical value n is equals to 5.1918. Okay, now I will figure out whether I want my n to be greater than 5 or my n to be less than 5. Well, my n to be 5 going down or my n to be 5 going up. Let's see about that. Okay, so when n is equals to 5, so let's say S5, what do we end up with? 3 minus 3, 1 over 3 to the power 5. Let's try 5. Okay, so I'm going to have 3 minus 3 multiplied by 1 over 3 to the power 5. When I substitute 5, I get 2.98. Okay, let me try substituting 4. Okay, when I substitute 4, I get 2.96. As you would expect, right? If the sum of the 5 terms is 2.98, then you would expect the sum of the 4 terms to be less than that, given that they are both positive. They are all positive, those terms. Okay, let's try s being equals to 6. I just want to check here. S being equals to 6. Replace 4 with 6. Let me do that. I'm getting 2.995, of which 2.995 is clearly greater than 2.99, right? 2.995 is clearly greater than 2.99. So the question is saying, calculate the smallest value of n for which the sum of the first n terms is greater than 2.99. So the smallest value of n is 6, right? I think these will be a bit confusing because you end up having n being less than 5.1918. I think some people would be tempted to say n is equals to 5, but clearly n is equals to 5 does not work for us here. What works for us is n being equals to 6 as the smallest value of n. Right, so moving forward, if I'm coming across a question like this, instead of using the inequality, I will quickly change it to an equal sign and justify by saying that I'm looking for a critical value. But anyway, stories 3.3 n is equals to 6. Here we go.